Chapter 5, Section 5.1. This section is about probability distribution. And in probability distribution, that we talk about random variables and in the probability distributions. There are two types of variables. One is the random variable, is a variable that normally we use the letter of X for it, that has a single numerical value determined by chance. Probability distribution is a description that gives the probability for each value of random variables. Now, these two types of random variable, one is the discrete, the other one is continuous. Discrete has collection of value that is finite or countable. Normally, you should be able to count the numbers. Continuous, it takes the decimal number, has infinitely many values, and the collection of value is not countable. And then the probability distribution, there are three requirements. As we go through the example, we go through all this. One is there is a numerical value for the X. X has to be a numerical value. Second is sum of the probability has to always be 1. And the third probability is always positive between 0 and 1. This is an example of probability distribution graph, which what is probability of a couple want to have no, what's the probability of out of two children, there are no girls, 0. There's one girl is 50% and 2 girls is 0.25. Now, first we want to find the difference between discrete and continuous variables. Discrete is countable, like in this example, is count of number of movie patrons. Movie patrons is countable. As people walk into the movie theater, they start counting the numbers. It cannot be a decimal number. It has to be a whole number because you are talking about people. Continuous random variable, it could be like voltmeter because it could also take the decimal, like voltage of a smoke detector. Now, these are some examples of discrete or continuous. Like number A is the number of statistical students is a discrete. We're talking about number of students, cannot be decimal, so it's a discrete. A square footage. A square footage, it could take a decimal numbers. What's the square foot is 70.7 square feet. So in that case, it's continuous. So again, main difference between continuous and discrete is a whole number, continuous can't take a decimal number. It's political party affiliation of adult in the United States, discrete or continuous. Is none of these two, is neither continuous nor discrete, is not a random variable. Is the number of people with blood type A in a random sample of 12 people discrete? Is discrete. We are talking about number of people. Is exact time. Times also can take to evaluate 27 plus 72. So time can take a decimal number. It's 3.5 hours. So that would be a continuous. Is the weight of T-bone steak. Weight can also take a decimal number. So that be a continuous. So this page describes the main difference between discrete or continuous variables. And the keys are here for you to practice. Now, one example is when you flip a coin. When you flip a coin, you either get head or tails. In either case, the chance is 50-50 or 50%. So when you flip the coin one time, you want a 50% chance of getting head and 50% chance of getting tail. Now, let's say the first one is head. When you do it the second time, you either get head or tail. Or if the first one is a tail on this tree diagram, when you flip it for the second time, you also get head and tail. So you go through the branches. These are all the possibility when you flip the coin twice. You either get both heads. First one is a head, the second one is a tail. The first one is a tail, the second one is a head, or both are tails. And these are all the possibilities. So like 0.5, you go through the branch, 0.5 times 0.5, 0.25. So they all have the same probability. Now, based on this, how do I create my table, distribution table? X, what's the probability of, let's say you have no head. In that case, no head means both tails, 0.25. What's the probability of getting one head only? These two, they both have one head. So it would be 0.25 plus 0.25 is 0.5. Excuse me. What's the probability of getting, in both times you get two heads? 0.25. Sum of the probability, sum of px always has to be 1. That's one of the requirements. Second requirement is probability always has to be positive between 0 and 1. It cannot be negative. So based on that, we could answer those questions. First question, what's the probability of 0 or no head? No head is just this one. Both are tail. So probability is 0.25. What's the probability of exactly one head? These two. So it would be 0.50. What's the probability of getting two heads? It's 0.25. So that's how you create your probability distributions table. So probability distribution has requirement. One has to be a numerical, X has to be a numerical value, not categorical. Sum always has to be 1 and the positive. Like in this one, this table, is this table meet probability distribution requirement? No, because X has to be numerical value. This is not numerical value. How about this one? X is a numerical value, but P of X the sum has to be 1. Since the sum is not 1, it doesn't meet probability distribution. See, so these two examples do not meet probability distribution. So for probability distribution, what you need to do, first you need to add all the P of X to make sure it's 100% or sum, and also make sure that X is always a number, not right response, not the categorical like this one. See, in this one is not. Why? Because the sum is 1.57, so that doesn't meet the requirement. Also, X is not the numerical value. Now, this example, I try to use two different methods. One method is, before we study these sections, if we give you a bunch of numbers, like a score of 10 students in a stat class are listed below. How do you calculate the mean? Mean is sum of all these numbers divided by number of students. So you add all these numbers divided by 10, that's 82.8. Now I want to do the same problem using probability distribution table. So X, 70, how many 70 do I have here? 1, 2, frequency is 2. How many 78? How many 80? 1, 2, 3, and so on. So formula is for probability distribution. If you want to calculate the mean is sum of xpx, means I need to find the probability. To find the probability for each, remember you take the frequency divided by n. So 2 divided by 10, 1 divided by 10, 3. That's how you calculate probability of x. Then you need to take x times px, means you take this x and multiply by px. And then x to px. X to px means you take this xpx and multiply by x. So I need to find sum of xpx, which is 82.8. I also need to find sum of x to px, which is these numbers. Now, remember, before you actually work on distribution table, remember, first you need to check to make sure that you have all the requirement met here. Now, standard deviations. What is a standard deviation? A standard deviation, this is the formula for a standard deviation, is square root of sum of x to px minus mean to power of 2. So I did these problems to show you how you calculate mean and standard deviation using probability distribution table. And these are the formula. Now, this is another example that I drew the tree diagram. Like a couple want to have 2 children. So what's the probability of the first baby is a boy? 50%, a girl 50%. Second one, it's very similar to flipping coin. So you either have both boys, the first boy and then girl. The first girl is a boy and girl. So these are all the probabilities. So when you want to create a probability distribution, what's the probability of no girls? Both boys, 0.25, 0.50. So sum of x px, again, is 1. Means mean is 1. How do I calculate standard deviation? From this formula. And in the past, we also had this formula that we use for binomial when you have mean and standard deviations. I'll show you that second method as well here. That's what we practiced before. But now, then is range rule of thumb for identifying a significant value. To do that, you always have to create mean plus 2 standard deviation and mean minus 2 standard deviations. Anything beyond these two is unusual. So if you look at this bell-shaped curve, any number greater than mean plus 2s or less than mean minus 2s is unusual. So they call it significantly high or significantly low. Now, on the first one, we have the answers here for you. They're talking about, are these the random variables? The random variable x, the number of girls. So let's go to the second one. Determine which one is discrete, which one is random variables. I have that on the second page for you. These are the keys, so you can practice. Now, these problems, the probability distribution is given. They want us to calculate mean and standard deviations. So these two columns are given in the problems. So you have to create xpx and x2px. So you xpx means you multiply these two, 1 times this, 2 times that. X2px means you take this xpx, like the value that you have here, and multiply by x. So that would be xpx or x2px. And sum of x2px you needed in the formula for standard deviation. But remember, before we do all this, you have to check to make sure that sum of these numbers is always 1. You have to meet the requirement. So sum of px always has to be 1. Otherwise, it's not a problem to distributions. Now, these problems, you could actually work on this one. It's very similar to that. They want to find the maximum value and minimum value and use maximum value and minimum value. So again, now what I did here on this one, I want to show you how to use the calculator rather than hand calculations. These two columns are given, okay? Before I work on the problem, first to see if the requirement of probability distribution is met or not, first you have to add all the px to make sure it's 100% or 1. If not, you cannot do the problems. Now I need to find x times px. I put all these numbers in L1 and all these numbers in L2. Then L3 is you multiply these two. So what I do is I put all the numbers on L1 and all the numbers here on L2. Now, what is L3? To find that, you go to L3 here, okay? And then when you enter, then you have to put L1 times L2 to get those numbers. That's how to find these numbers. Now, if you want to find L4, go all the way to the top. What is L4? L4 means you have to take x, which is L1, times L3. So while you're there, you just say enter, you just say L1 times L3. And that gives you all the numbers that you need here. Okay? Now, if you want to find sum of xpx, because sum of xpx is what? Sum of xpx is the mean. So if you want to find sum of all the numbers that you have in L3, just go to stat. I'm going over this. Go to stat, calculations, and here put L3. I'm following this instruction for this one. This sum that you see 5.708, this is sum of xpx using the calculator. Okay? Now I need to find sum of x2px or sum of L4. So in that case, again, you go to stat, you go to calculations first, it just changes to L4, second, L4. And when you do that, the sum, which is 2901, that gives you sum of x2px. So when you have all this, you plug it into the equations. That gives you a standard deviation. Now, the problem asks for the maximum or minimum, okay? So this is the max, and this is minimum, which is mean plus 2 standard deviation, mean minus 2 standard deviation. So that is easier to use the calculator, so you don't have to do all the hand calculation. So that avoid any type of mistake when you do hand calculations. This one, the table is already given, again, and then said, find the probability of exactly 1 GER. Exactly 1 GER is just this. Second, find the probability of getting 1 or fewer. 1 and fewer means this, x less than or equal to 1. So that would be a probability of x equal 1 and probability of x equal 0. Means all I need to do is just add these two. And the multiple choice question, the answer is there. Again, the table is given. First, you add all these px to make sure that px, the sum of px is 1. Make sure that sum of px is 1. And then, what is sum of x equal 4? 4 is 0.06. What is when you have 4 or more? x is greater than or equal to 4 means you just add these two, and so on. And the rest is just all multiple choice that the answer is on the last page.